Hi everyone, welcome back to VRC Smart Edu channel. So today we are with chapter 10 Haloalkanes and Haloarenes part 5 video. So in this video we are going to look after the reactions of haloarenes. Okay, it's very important, reaction of haloarenes. If you have not watched the previous session, the links are provided in the description. You can go and check it out. And the previous link is popping up here. You can go and check that also. So you can watch a previous session so you can get the complete clarity on all the concepts. So but in this video we are going to look after the reaction of haloarenes. Okay, already we saw about the reaction of haloalkanes, different types of reactions, right? We saw about the nucleophilic substitution reaction, elimination reaction, and we also studied about the reaction with metals. Similarly, here also we study about the reactions of haloarenes. Okay, let's quickly move on to today's topic, reactions of haloarenes. You all know what is haloarenes earlier, right? Haloarenes are nothing but in the aromatic carbon, that is benzene, one, instead of a hydrogen, a halogen will be replaced, that is haloarene. Clear? So now reaction of haloarenes, there are three different reactions that we are going to study. The first one is going to be the nucleophilic substitution reaction. Nucleophilic substitution reaction, and the second one is going to be the electrophilic substitution reaction. Electrophilic substitution reaction, and the third one is going to be reaction with metals. Reaction with metals. So we will be looking after all these three things. One is nucleophilic substitution reaction, electrophilic substitution reaction, and reaction with metals. Clear? This is one of the most important topic that you have to concentrate. Okay? Okay. Now let's move to first nucleophilic substitution reaction. While seeing the nucleophilic substitution reaction, one thing I have to say here. See, you know aryl halides. What are aryl halides? What are aryl halides? Haloarenes are called as aryl halides, right? So all aryl halides are less reactive towards nucleophilic substitution reaction. So aryl halides are less reactive. That means they are not that much reactive. They are less reactive. There will be less amount of reactive towards a nucleophilic substitution reaction. So there are certain reasons why they are less reactive towards nucleophilic substitution reaction. Let's see those reasons why they are less reactive towards nucleophilic substitution reaction. Those reasons are also equally important here. Clear? So you have to remember the reasons also. Okay. So if you just see the first reason. So A1 is going to be hybridization. Hybridization. So when you take about the aryl halides, okay, you have the benzene ring, okay, and you have the Cl attached. So what is the hybridization of this carbon? For all the carbon, the hybridization of all the carbon is going to be sp2 hybridization. So this can also be one of the reason for less reactive towards nucleophilic substitution reaction. Then B1 is going to be instability of phenyl cation. So that is, you are going to have the phenyl, okay, in that phenyl you are having that cation, in the sense positively charged. So instability of the phenyl cation, it is going to be the another reason. Okay, so next one is going to be the C1. C1 is going to be repulsion. Repulsion between electron-rich nucleophile and electron-rich nucleophile and electron-rich arene. So there will be causing a repulsion between the nucleophile, electron-rich nucleophile and electron-rich arene. So that can also be the another reason. And D1 is going to be the resonance effect. Resonance effect. So when you talk about the resonance effect, so first we will be having the resonance effect is simply nothing but bond shifting. You will shift the bonds, and finally what is the resonance image that you are going to get? That is what we are going to see. First I am going to take the benzene ring. Okay, benzene ring with Cl attached, and it's going to have the valency of 6 electrons. Now what is happening is this bond of 2 electrons is going to shift over here, and this bond is going to shift over here. Now after that, to show the resonance effect, you will show the double-sided arrow mark, and you will have the next resonance image. There what happened is the Cl, the bond is getting shifted here. So here double bond you will get, and Cl you will get with positive cation, and your bond had been shifted here. So these two bonds will be same as it is, but this bond is shifted now. Here it will become negative and it is going to shift over here. Next resonance image you are going to draw, where you will have the benzene ring again, and again you will be having the double bonded Cl with positive. Okay, now what you are going to do is, now this bond will be as it is. Now this negative symbol is coming inside, so here the bond will be created, and this bond will be going out. So this bond will be making the negative symbol, and this will go in. Okay, next image will be, you will have the benzene ring again. Your benzene ring, you will be attached, it will be attached with Cl with double bond Cl, and here positive cation will be there. Now what happened is, now you know that this bond will be as it is. Okay, your this bond will be as it is, and this bond will be shifting over here. Okay, so here this bond will be there, here this bond will be there, and this bond had been shifted, right? So here negative symbol will be there, and this will be shifting over here. Clear? This had shifted, so this will be shifting over here. Now again the final resonance structure, the bonds will be, it has been shifted over here. So here one bond, here one bond, here one bond with Cl attached. This is how you will have your resonance image. So because of the resonance effect also, it's less reactive towards nucleophilic substitution reaction. Clear? So now let's move on to the replacement of hydroxyl group. In the replacement of hydroxyl group, first we are going to start with the first equation. So replacement of hydroxyl group. Here, first if you just listen here. First I am going to take the haloarene. Haloarene, the benzene ring with chlorine attached. Okay, so I am going to make it under NaCl. It is going to go under NaCl at 623 Kelvin. At 623 Kelvin, 623 Kelvin and 300 atm, that is atmospheric pressure, 300 atm in the presence of H plus. You will get benzene ring with OH attached. Okay, phenol. You will get phenol, benzene ring with OH attached. Now that is what? Hydroxyl group, right? So next we are going to have the benzene ring with Cl attached, and in the presence of NaOH, NaO minus plus H plus, you are going to get benzene ring with ONA plus. So this ONA plus is going to be there. This is called as sodium phenoxide. Sodium phenoxide. And in the presence of again HCl, H plus and Cl minus, it's going to be splitting into, you will get benzene ring with OH attached with the liberation of NaCl. Okay, so OH, O is negative, so H will be getting attached to O, and NaCl, Na is positive and Cl is negative, so NaCl is coming out. Okay, similarly here also NaO, right? So NaO is going and attaching, O will be the negative part, so it will be attaching instead of Cl. Okay, and HCl, it is H and Cl is going out. Okay, as HCl. Clear? So in replacement of hydroxyl group, we are going to see the third one. Third one in the replacement of hydroxyl group. First, you are going to have the benzene ring. There, what will be attached? There Cl will be attached, and as well as NO2 will be attached. NO2 will be attached and Cl will be attached. Now, in the presence of NaOH, at 443 Kelvin, in the presence of H plus, you are going to get the benzene ring. So normally draw the benzene ring. Okay, NO2 is there, so only NO will be attached. Only NO will be there, and at the top you will be having the OH group. See, hydroxyl group, when replacement of hydroxyl group is there, you should surely know that OH will be attached. That is a hydroxyl group. So surely you will be able to observe hydroxyl group. Okay. Next one. Similarly, now again you have the benzene ring where your Cl is going to be attached, and NO2 is attached at both the places. Okay, two places NO2 is attached. Again in the so here also what will be attached? NO2 will be attached and NO2 will be attached. Okay, now fifth one, final. Now you will be having the same way benzene ring with Cl attached, and here three places you are attached with NO2, NO2, NO2 and NO2. Now in the presence of H2O under warm condition, what you will get is, you are going to get OH attached in the benzene ring with NO2, NO2 and NO2. Okay, so this is how you are going to have the replacement of hydroxyl group. Clear? Moving on to electrophilic substitution reaction. Already we studied about electrophilic substitution reaction in our class 11. Okay, so we studied about the 5 electrophilic substitution reaction: nitration, halogenation, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. The same we are going to read here, but with the attachment of Cl or any other halogen matter. That's it. That's the difference. Okay. Now let's see here. Easy, only the same way you are going to write how you have studied in your previous class. Okay. So first you are going to take the benzene ring. I told as it is, Cl will be attached. So for first one is going to be nitration. A is nitration. Okay. A is nitration. So in nitration, what is going to happen? First you will be adding the concentrated HNO3 and concentrated H2SO4 sulfuric acid. Okay, so first you will be getting the See, your HNO3 will be breaking up into NO2 and OH minus. So OH minus it's breaking, right? So now you will be getting the product with NO2 attached and this H2SO4 is there. So that will be going out as a product H2O. Okay, there. So you can able to see that you will get a product of benzene ring attached with Cl and attached with NO2. So based on the position you have two different types of product. If NO2 is attached here and benzene ring with Cl, okay, and NO2 at the bottom, okay. Based on that, based on two positions you have the name. This is going to be 1-chloro-2-nitro-benzene, correct? The name given here is 1-chloro-2-nitro-benzene. What is the name given here? 1-chloro-4-nitro-benzene. So the two different names are there. Here one is going to be the major product and another one is going to be the minor product, but with the liberation of H2O it will be. So one is going to be the major product, another one is going to be the minor product. So here if NO2 is attached in fourth position, then it is going to be the major product. Okay, second position it's going to be the minor product. Clear? So it's all about the nitration. Okay, next moving on to halogenation reaction. Halogenation. Okay, so in halogenation reaction again I am going to take the benzene ring with Cl attached and I am going to add Cl2 in the presence of anhydrous AlCl3, anhydrous AlCl3. So you are going to get the benzene ring with already chlorine is there, again one chlorine will be attached. Here also two positions are seen where chlorine is going to be attached. Okay, so plus HCl will be liberated. Okay, HCl, one Cl will be going and attaching and HCl will be liberated. So now listen here, what is the name you can give to this compounds? What is the name you can give to this compounds? It is going to be 1,2 dichlorobenzene. It is 1,4 dichlorobenzene. So what is the major product here and what is the minor product here? So here the major product is going to be, again where Cl is attached in the fourth position, that is going to be your major product and your second position is going to be the minor product. Clear? So this is going to be your major product as it is and this is going to be your minor product. Clear? So now we are starting with sulfonation. So your C1 is going to be sulfonation reaction. Okay, sulfonation. Now here also we are taking the benzene ring with chlorine attached. Okay, in the presence of H2SO4, what you are going to get is here also two products you will get based on the position. Okay, based on the position two products you are going to get. Okay, one is going to be your SO3H will be attached here and another product where your SO3 is going to be attached over here, 3H. Okay, so based on this you will be having the major product and minor product. So first before that let's give the name for this compound. It is going to be 2,2-chloro benzosulfonic acid. Sulfonic acid. This is 4-chloro benzene sulfonic acid. So you yourself can determine which is going to be the major product and which is going to be the minor product. And this one is going to be the major product and this one is going to be the minor product. Okay. Next. So now we are going to see the Friedel-Crafts alkylation reaction and Friedel-Crafts acylation reaction. So first, our fourth one or D is going to be Friedel-Crafts alkylation reaction. So actually this Friedel-Crafts alkylation reaction is a name reaction. So it is very important. Okay. It's very important. So at the final of this video, I'll list out what are the name reactions we have studied till now, and those all name reactions are very important, and those are the name reactions in this chapter. So you have to be thorough with that. Okay. So Friedel-Crafts alkylation reaction. For that we are taking the chlorine attached with the benzene ring in the presence of CH3Cl, in the presence of anhydrous AlCl3. What you are going to get is you are going to get the benzene ring with CH attached, CH3 attached, and Cl will be attached. Here also you will be having two different positions. Okay, here also you will be having two different positions of attachment of CH3. Based on that you will say whether it is minor product or whether it is the major product. Okay, this is going to be 1-chloro 2-methyl benzene. 1-chloro 2-methyl 1-chloro 2-methyl benzene. This is 1-chloro 4-methyl benzene. Based on the area, which is going to be your major product and which is going to be your minor product. So it is going to be your major product and this is going to be your minor product. Okay, remember this is a name reaction, so it is very important. Okay, next we are going to go for Friedel-Crafts acylation reaction. So Friedel-Crafts acylation reaction. So let's start doing the Friedel-Crafts acylation reaction. It is also a name reaction. Okay. So here also we are going to have the chlorine attached with the benzene ring. Okay, chlorine. And here we are going to take is CH3COCl in the presence of anhydrous AlCl3. We are going to get the benzene ring with Cl and COCH3 attached. So the placement of COCH3 is also two different types of placements you will be having. Here also COCH3 will be attached and Cl will be attached with the liberation of HCl. Okay. So the names will be given for these compounds. Two different names are given here. So here it is given as 2-chloroacetophenone, 2-chloroacetophenone, and this can be given as 4-chloroacetophenone. So now you yourself can guess which is going to be the major product and which is going to be the minor product. This is surely going to be the major product and this is surely going to be the minor product. Clear? What that? Yes. Now we are going for the reaction with metals. Under reaction with metals, we have two different types of reactions. So your first reaction is going to be fitting reaction. Fitting reaction. So this is also one of the name reaction. So it's a name reaction. Okay, it's a name reaction. Now let's see what is a fitting reaction. Okay, so fitting reaction. Similarly, you have the benzene ring with X attached. X is nothing but it can be chlorine, bromine, or iodine. and we are going to add 2Na. So here again you are going to add the benzene ring with X will be attached. Okay, here X is attached. Now what is going to happen is, in the presence of dry ether, we are going to get biphenyl. Biphenyl. Okay. So biphenyl, something like this it will be. This is called as biphenyl with 2 NaX will be liberated. 2 NaX will be liberated. Okay. I'll write that clearly. So with the liberation of 2 NaX. Clear? Okay. Now let's move for the next reaction. B1. B is going to be Woods fitting reaction. Woods fitting reaction. So what is all about Woods fitting reaction? Similarly, you will be having the benzene ring with X atom attached. X can be chlorine, bromine or iodine with 2Na and CH3X is attached. CH3X in the presence of dry ether. Similarly, in the presence of dry ether, you are going to get the toluene. Okay, that is, you are going, instead of X, your CH3 will be replaced. You will get the toluene with 2NaX liberation. With the liberation of 2NaX, you will get the toluene. Clear? So that's all for today's video. Thank you so much for watching this video, and meet you in the next video. So watch all the parts till now to get the complete clarity, and thank you so much.